let's talk about time travel. Now, it sounds like pure science fiction, right? Well, it turns out it's a real, genuine cosmic debate. It's this wild place where our two biggest, most fundamental theories of the universe, one for the very big, one for the very small, smash right into each other. And in this explainer, we are going to dive right into that collision.
So, here's the core of the problem. On one side, you've got Einstein. His masterpiece theory of gravity actually has the mathematical blueprints for a time machine baked right into the equations. No joke. But then, on the other side, you've got the bizarre rules of quantum mechanics, which seem to act like this cosmic bouncer standing at the door of reality and saying, nope, you can't do that. So which one wins this cosmic tug of war? Who's right?
All right, let's start in Einstein's corner. You see, it turns out that general relativity, our absolute best description of gravity, does way more than just tell us how planets orbit stars. It kind of secretly cracks open a door to the past.
I know, it sounds completely impossible, but buried deep inside those elegant equations that govern space-time itself, there are actual, legitimate solutions that permit paths not just forward in time, but backward. And let me be super clear here, this isn't some rounding error or a mistake in the math. These are real possibilities that the theory itself predicts.
So, what are these loopholes called? Well, the fancy physics term is a closed timelike curve, or a CTC. But honestly, the best way to think of it is as a cosmic highway. Imagine getting on this highway, and if you follow its path, you loop right back around to the exact place and when you started. Wild, right? You could literally live it all over again. Or, and this is the big one, maybe even change it.
Okay, so where would you even look for one of these cosmic highways? Well, the theories point to some of the absolute weirdest, most extreme places you can imagine. We're talking about the spinning heart of certain kinds of black holes, or a theoretical universe that's actually rotating as one giant object, or maybe even hypothetical cracks in the fabric of space-time called cosmic strings. I mean, this is seriously mind-bending stuff, but the math says they're on the table.
But, and this is a huge but, this incredible idea smacks right into a massive reality-breaking wall. And that's the problem of paradoxes. Because if you can change the past, can you accidentally erase your own present?
This is the one question that just haunts the whole idea of time travel. And it's not even about complicated physics. It's just simple logic, right? An effect cannot get rid of its own cause. The moment it does, the entire chain of events just poof, collapses into a messy contradiction. The classic example is, of course, the grandfather paradox. Let's walk through it. Step 1, you hop in your time machine, you go back to the past. Step 2, you do something to stop your grandfather from ever meeting your grandmother. Step 3, you're never born. Which leads us to step 4, if you were never born, who went back in time in the first place? See? It's this perfect, inescapable loop of nonsense that just shatters reality.
So what gives? Does the universe just allow this kind of thing to happen? Well, probably not. And this is where quantum physics marches onto the stage, possibly acting as a kind of cosmic security guard, here to protect causality itself.
This idea actually has a name, and it comes from the legendary Stephen Hawking. He called it the Chronology Protection Conjecture. And it's pretty much exactly what it sounds like. It's the idea that the fundamental laws of physics are actively working against you, conspiring to prevent time travel from ever happening. The universe is literally protecting its own timeline from being rewritten.
So how would this protection actually work? Well, there are two main theories. On the one hand, you've got Hawking's version, which is pretty brutal. Basically, the moment a time machine starts to work, quantum energy goes haywire, spiking to infinity, and just boom, it obliterates the entrance. End of story. Then, on the other hand, there's Novikov's principle. It's way more subtle. It says, sure, you can go to the past, but physics will physically prevent you from doing anything that wasn't already part of the story. You simply can't create a paradox because the universe won't let you.
But what if quantum mechanics isn't the enemy of time travel? What if it's actually the solution? What if there's a third, much, much weirder way to have your cake and eat it too, without breaking reality?
This is where physicist David Deutsch comes in with a seriously cool idea. He suggested that, thanks to quantum weirdness, when you travel back in time, you don't just take one single path. You exist in all possible paths at once. It's called a superposition. It's like you're a ghost trying out every possibility. And then the universe itself just
settles on the one outcome that doesn't create a paradox. So it's not about stopping you, it's about making sure the story always makes sense in the end.
And get this isn't just some theory on a blackboard. Scientists are actually testing these ideas in labs right now. They're sending single photons, particles of light, on journeys that simulate these time loops. And the results so far are amazing. In these quantum experiments, causality holds up. The paradoxes that we think should happen, they just don't. So let's just step back for a second, because this entire debate, it goes way beyond physics. It forces us to ask some really deep questions about the nature of time, about reality, and about our own place in all of it. I mean, the implications here are absolutely massive. If time travel is possible in any form, it might mean we're living in what's called a block universe, where your past, present, and future all exist right now simultaneously. It could unlock computational power that's totally beyond our wildest dreams. But man, it also opens up a huge Pandora's box of ethical dilemmas. I mean, think about that. Does it mean your entire life, from start to finish, is already laid out, all existing at once? And if you could visit the past, what are the moral dangers? Who gets to decide what parts of history should be fixed? Could our shared reality, the past itself, become nothing more than a story that anyone with the right technology could edit?
And that really leaves us with the biggest question of them all. Is causality, that simple, intuitive rule that cause always comes before effect, is that a hard and fast law of the universe? Or is it just a stubborn suggestion? Maybe it's just a habit of our perception, inside a cosmos that is far stranger than we can possibly imagine.